Alright, so I've got a turret here, just as a sample. I just want to go over um, the kind of steps that I take when it comes to rigging a mechanical object like this. Um, Usually when you're doing armatures and stuff like that, it's for characters, but a lot of times, especially with modern engines, you can do quite a bit with vehicles and things. Um, Such as like Arma. We're going over to Reforger, starting to get some better tech for that. Um, so I just wanted to go over what it takes to rig something simple like this while covering the basics of what you're probably going to be looking at. I'm going to be going over armatures, um, how they parent to objects like this, um, and also how generally the workflow we're looking for, or the hierarchy rather, we're looking for when it comes to armatures going into games. So with that, I will just get started here. So I've got the box, I've got the base down here, and I've got the turret here. You'll notice I actually have the entire thing as one singular object. But if I go in here and I press L, each of these is not welded. And I prefer it that way because if they're welded, they're really hard to work with until the very end. If you have some special need to weld it together, you can do that by separating things out and then adding them back together with like a Boolean modifier, but we're not going to go over that today. All I want to go over is setting up the armature to make this part of the arm here, this whole part here. I'm just pressing L to get this. Actually, you know what? That's not helping my example. Here we go. This whole thing, I'm going to X-ray mode for a second, grab all that, hit L again, because I goofed that a little bit. All right, now with that there, I can set this to rotate around cursor. This is a very helpful trick, by the way. Back to the point though. If I want to rotate this up and down, let's see, I'll probably go over some limits there, because obviously if I go too far, you'll start phasing right through it, which we don't want to do. We also need this barrel to rotate like this without any unusual deformations. We want that to be steady. So ideally we want both of these to happen at the same time. So what I'm going to do is I'll go ahead and exit out of the edit mode there, go back to object mode, set the cursor to world origin. You can probably see in my keylogger there at the bottom right, I'm holding down Shift and S. Again, this is kind of a video for beginners who are switching over from other modeling softwares. Now that we've got that in the center, I'm going to Shift A, armature. I just want a single bone. And right away I'm going to rename this bone. I'm going to go into edit mode, rename this bone to root. And I actually want to rotate this forward because I want to indicate which direction the whole body should be facing. This is probably not relevant for this particular example. When it comes to other examples, though, you really want to indicate which way is forward as often as you can. There's not many examples where um, having a forward direction is not going to come into play at some point or another. And then, anyway, so I'm just going to go back and grab this center ball here. I'm going to press E to extrude. I'm going to go ahead and raise that up. And this actually, even though it's down here, so right away you can see this is actually not connected. These two are not connected to each other. I believe they're hierarchically separated as well, yeah. So what I actually need to do is I'm going to rename this from root to turret. And what I was going to say before, even though this is down here, it's going to rotate this whole thing. And by the way, I know you can see through all this. This is just to try to make it a little bit easier to see what's going on without having to turn on in front, because then the whole thing just, I personally don't really like it. I will use it, but I don't like it. So this is just temporarily just to give some x-ray, just to fake an x-ray here. Anyway, back to the point. So this is the turret. this bone right here is going to be the turret. And I need this. I need a second one. I'm going to move where you can select the armature bones and the vertexes, like the vertices at the same time. I've forgotten how to do that because I never do it. Back to this. So these groups are empty. They're completely empty. I'm going to actually go ahead and double up on this. Control P with empty groups. And I'm actually going to join these two together because there's actually no reason not to in this case. So we grab everything. I'm just going to go ahead and put that to the root. Assign. We got the weight set to 100. So this entire object is now fully assigned to the root. So if we go into, click on the armature, go to pose mode, then grab the root and move the whole thing around, you can see that's moving around. But you also see that these are not following. That's because I actually did not parent these armatures together. So I'm going to go back into edit mode. I'm going to click on this, and this is manual parenting. You should be doing this a lot. I'm going to Control P and then keep offset. If you connect it, well, your rotations are going to be weird, and they're not going to be perfect, and they're going to result in artifacts that you don't want. So keep offset. That keeps this where it was. Otherwise, this would have gone down to this, and we don't really want that. That's, well, it's already, yeah. See how it's rotated all strange now? We don't want that. Control Z, put that back. Now these are connected. I'm going to do the same thing with this. Select the bone that I want to become a child. Then I select the parent. Control P. Keep offset, because why not? This could change. This skeleton could change at any point. The important part is that this arm, these are connected. That's fine. That can stay the way it is. Although technically you could separate them by pressing Y, and now they're separated, and you would want to reparent it by keeping it connected. And just to illustrate my point, I'll keep it that way. Go back to the object, edit. Now I need to assign the parts that are going to move. So I just want this and this to be part of the turret group here. Assign. Now I'm going to grab this and this, pressing L again to quickly select the entire connected vertices. I'm going to select gun, assign. At this point, we're already seeing ooh, ooh, that's interesting. That shouldn't be happening. Remember that thing I did earlier where I grabbed the entire object and then assigned it to the root? Don't do that. Instead, make sure that there's nothing assigned to the root. The root will never move. If you need to have an extra bone there, I'm going to go ahead and make an extra one. And I'm going to call this base. So in Blender, what you need to do, make sure you always have set up correctly, is you want to only have weights assigned to bones that are actually going to be moving the object. So now that I've added a new vertex group there, plus add one, rename it, make sure it is according to the bone you're trying to name. Yep, base, yep. And now that I have actually, so if you've done this, if you have accidentally assigned way too much to a single bone, can do is click select here, and that will, if there's anything that is part of that group, it will select it, such as the base here. Oh, I didn't assign it. So highlight that, assign, deselect, then select, and it should bring that back up again. That's the easiest way to find how things are selected. Yeah, so in this case, that's good. That's good. That's exactly what I want to see. And then I still have to do this one. So select, hold L, not hold L, tap L, assign this to the gun barrels. And now we should actually be good to go. So this solves the squishing problem. Make sure that you are not, because what was happening is that the armature was fighting with the root bone over which one is right. The root bone wanted to stay in its default pose, and the other bones wanted to deform the mesh the way they wanted to, and it resulted in some weird halfway in between thing because Blender doesn't by default normalize its weights. You have to tell it to do that. In this case, because we're doing a mechanical object, you don't need to do that. You don't need to normalize the weights. You just need to grab the vertices you want to use and then assign them individually. So now that we've done that, I'm actually going to put this in front, make it a little bit. All right, now that we've done that, I can rotate this around the object's pivot point. And then, if I want to rotate the barrels, I can easily do that by pressing R and then pressing Y to lock it on the Y-axis, the local Y-axis. Actually, local. Sometimes it's better to do this. Make sure you have this set to local. Changing it to local does actually change the axes you're working with, because it's changing it to the local space for this bone, or this bone, or this bone. So now, with that all out of the way, this object is rigged, but it doesn't do anything. It has no poses, it has no keyframes. So we're gonna go ahead and add some keyframes to this. Right away, I'm gonna go ahead and select everything, and at 0 here, press I while hovering over the, make sure that this is the timeline. Under animation, you click this little button right here, timeline. And you could go into dope sheet stuff. I don't want to get into all that right now. Just stick to the timeline. Here, press I. That will add a keyframe to the timeline at that particular key. So at that particular frame. So at 0, we have our default pose. And I like to kind of stretch that out a bit, add one more. And you'll see Blender gives you this little orange highlight here to show that nothing's changing between these two frames. And from here, at 5, let's say I want to make a 15 frame animation where the turret rotates. I would never do this in a game because unless you're trying to do like a baked animation. So if you're baking an animation with keyframes, you need this to work like that. You would, for instance, now that that's been moved to that place, don't move it from this frame. With this frame selected and this rotation created, I'm going to press I again. And what this has done is going to tell Blender to interpolate between these two. Interpolation can be turned off if you really want it to just snap directly to that frame. I'm not going to be doing that again. Let's go ahead and bring you back to where you were. In fact, the easiest way to do that is to select one of the earlier keyframes from your reference pose. Control C. And let's bring that out to, what was it, 15? So 35. Get to 35, or maybe 36. And then Control V, paste that pose back in. So now, you get a little head turn here. And let's go ahead and create another gap right here. And the reason I'm doing it like this, instead of using the dope sheet and making a bunch of actions, is because a lot of engines don't really play nice with Blender's actions. Exporting those, it's kind of a pain. Doesn't really make a whole lot of sense. It works great inside of Blender, but outside of Blender, it gets a bit messy. Usually what you can do instead is grab reference points. So like when you are importing this as an FBX into a game engine, um, for the animation options, usually it gives you a little frame range. So in this case, you would have the animation start at 0 and then tell it to end at 5, and that would be your idle pose. In this case, starting from keyframe 5 to 36 would be your head look. So when you're importing the animation, you would indicate to the game engine that frames 5 through 36 are their own animation, and those would usually import separately. So what you would do is you would drag it into the file over and over again. There might be a better way to do it in some engines. I know that in Unreal Engine, you can typically just kind of re-import the same thing multiple times, or import the entire thing in one chunk and then separate the keyframes out in the editor. Hopefully you can do that in your own game engine. Now for the spinning. The spinning is not really... So here's a cool thing about this. I'm going to start at keyframe 5 here. So we've got this. Nothing's happening. If I wanted to, let's say about here. I just opened up this side here, item. Let's go ahead and do a little test here. So it should be the z-axis, because it's local. Yes, okay. So what I've done here, it's getting a rotation to work, like a constant rotation, is actually kind of difficult. So what you want to do instead, for the most part, unless you have a very specific need to have a very precise rotation. So let's say you rotated 90 degrees in 15 frames, because that's what we have set up here. You could do that. And then the barrel will rotate 15 frames. In fact, let's do that again. From 36. Another 15 frames. And rotate that back 1 to 0. Then press I to add that new keyframe. So you'll see that it did rotate 90 degrees. And if you're trying to loop this animation, that actually should be enough if you needed to do that, because then you would just repeat that over and over again. Alternatively, you could, now that I've done that, add another 15 frames. Let's see, where was I? So this should be 70. So at 70, I could... Hi, Editing David here. I realized in this next clip, this next addendum, I did not, in fact, include the quaternion to XYZ Euler conversion that I did. Originally, this barrel assembly would not continue to turn with the control bone, which you will see here in a minute, because it was set to, this bone in particular was set to quaternion. I had to change this to XYZ Euler. If it is set to quaternion, it will turn once and then never again. If it is in XYZ Euler, it will continue to turn forever and ever and ever, as long as there is motion feeding the driver, which you're about to learn about. Okay, bye. All right, quick addendum here. Ran into an issue with some of the new driver tech that we've got going on here. I never really got too into drivers, but with a little bit of finessing, I was able to get this to work the way I was expecting to. So what I've done here is I've created a, you see a second bone that I've made here. And what I've done is I have, so, okay, back it up for a second. So this bone here controls the rotation of this barrel. And what I've done is I have mapped the rotation of this to this, and then this bone's rotation is driven by this bone's location. So if I pull this out on the z-axis, it rotates the whole thing. And I know what you're thinking. Why didn't you just put the driver directly on this one? That's the problem I ran into in the last little stretch of the video here, where I tried to right click on this and I was like, huh, where are the drivers? Well, it looks like the reason that there are no drivers on this particular bone is because this particular bone has keyframes already. In fact, now that I've applied the drivers, the keyframes are now useless. But in any case, that's neither here nor there for the moment. What we can do now is, starting from this point, make a keyframe here, stretch it out to, let's say, where was that? 101? Let's say 131. Actually, no. Let's give it 10 frames because I want it to spin really fast, right? So now, let's take this and we're going to rotate it. We're going to bring this out until it makes a full rotation. That should be about, let's look at it from the front. It's 90. Right about there. So the closest that would probably be 0.25 meters in this case. Oh, no, actually, it's a little bit off. I've never been great at math. Don't tell nobody. Anyway, the basics is you can now take this, drag it out here, go ahead and add another keyframe. So now what'll happen is that when I play the animation, it'll rotate extremely fast. Let's slow that down. Buzz it back to where it was. In fact, clear transform. Put it back where it used to be. Very handy. Very handy. Always use that. I'm going to add another keyframe right here in our reset position. Let's stretch this out. Yeah, that's good enough. And go ahead and drag this out nice and far. Let's say 1 meter. 1 meter's good. Add another keyframe. So now, even though I didn't add a keyframe to this bone or this bone, we can still get a fully baked animation. Hi, Editing David here one more time. I noticed in that last little stint there, the barrel was, rather than having a consistent smooth motion all the way through, that you could play back in a, 30 frame loop over and over again, it would look nice. Instead, what I had done is I had left the interpolation mode to the ease in, ease out mode, which caused it to ramp up into its speed and then slow down as it reached the end. Not critical for this example, but it was serving as a bad example, because if you were actually going to do this, you would want to make sure that the interpolation mode here is set to linear. Not constant. Constant will give you this weird stop motion look. You don't really want that. Bezier is closer to what we had. It's great for doing creature animations, but if you're doing like a something that has to loop back to back to back, you do not want Bezier. You're going to want to stick to linear for stuff like that. But as always, you have lots of different choices here. Like, you can grab different things and change them to be however you want. In fact, I'll just show you the stop motion here real quick. Boop, boop. Yeah, jarring. Doesn't even look like it moved, but it did. Anyway, that's it for that. I will get you back to the video. because this bone is driving the rotation of this sequence here. Now, to get into the actual driver itself, um, what's going on here is I've added a constraint to this bone. You see here the copy rotation constraint. I didn't change anything here. I just went straight in and told it to copy this bone. So all this is doing now is it's overriding its own rotation with this thing's rotation. In fact, I could replace that with add. And that would actually allow us to keep our old frames. Yep, there we go. Keep our old frames and then add these new crazy ones that are driven by ad hoc math and dreams to the sequence here. So, going back to what I was doing. So what I've done is on a fresh bone like this, one that doesn't have anything going on, no keyframes at all, this is going to be my target for this rotation. So what I did is I went into the rotation. Since we're on the local axis, this is technically the Z rotation here. So I right-clicked on this, and I went to, let's just use this as an example, add driver. Now once you've added a driver, I'm going to go ahead and edit the one I have here. What you can do with this checked scripted expression, because I tried it the other way, so I couldn't really figure that out. And here's your expression right here. And this is just saying whatever this variable is times 25, because I really wanted it to spin. I wanted to sell the spin. I didn't want to have to pull that bone out very far to get it to get a full rotation. You can check this if you want to. I don't really know what that would do. But the way you would add the driver here is add an input variable, which I did. I got this, and I have this set to transform channel because I want the transform data from this bone here. And I'm taking that, so you have object armature, it's referencing itself, bone gun barrels 001, which happens to be this one over here. So gun barrel 001, that's this one. And we're getting the Z location from this bone in local space. So in its default pose, you won't see any changes. But as soon as it moves, you'll see the difference. You see the value is already set to 1. If it was in its default position, let's go ahead, clear transform location, back to edit driver. See, now the value has been reset back to 0. It was at 1, now it's back at 0. And with this, the way this is set up, and I have the variable set here to var, it's the same thing. This expression is referencing this input right here. So whatever this is, you have to make sure this is the same thing, this particular thing. Otherwise, nothing will work. And that's the basics of how to make that driver work. You can make this do a lot of crazy things. Just for this example, I wanted to get the gun barrels to actually, spin wildly. This would be useful for baked animations. Baking the animations is a little bit outside of what I'm trying to do here, but the way that I understand that is I would actually go to object, grab the object I want to export, grab the armature that is driving it, export as FBX, selected objects, down here to animation, all actions, it's fine. And then exporting it should bake the animation, this whole timeline, into that FBX file. Anyway, hopefully that helps with figuring out how to get something like this to work without having to backtrack too much like I did. I was doing a little bit of learning on my own here because some things have changed since the last time I touched them. And yeah, I hope this helps, and I'll see you next time.